as I'm putting this on, I also want to mimic what Danny had said to everyone here, because I think everyone is growing. I appreciate that because it makes our job easier. It helps us be able to take on more. It also brings you up to the next level, which allows the guys above you to go to the next level, and allows me to go to the next level, allows Danny, and so on and so forth, right? So that's how a company grows, by people taking on more responsibility so that their overseer can take on more, and so on and so forth. So it is working. I'd like to think, I'm actually certain of it, that this has helped. It definitely has helped us. Like Danny said, it shows us who's committed. And that's a real, real important factor, because any company in our position will look at that and say, we're going to invest in the people that are committed, because that's a solid investment. Okay? If a person doesn't show commitment, why would a company invest in that? As much as the people that are committed. So, we're all in a really good position right now. You being here is not only good for us, it's good for yourselves, but it's good for the company as a whole. Okay? Because we are moving on. The other thing is, we talk a lot to the Department of Buildings, other people in the industry, property managers, and it's helped because they're also saying to us, the other companies are following us. We're setting the standard. This is coming from DOB. DOB is saying, you know what, you guys are setting the standard, and everyone else has to follow you to get up to your point, or to stay within your level. So getting that from the industry, not within our company, is a big thing. So that also helps out and confirms that what we're doing as a company really, really is working. And I think we all have a lot to be proud of. I think, Danny, you have really a lot to be proud of, because he's taken this like the bull by the horns. When all this work started coming in, he says, let's do it. We can do it. We can do it. We can do it. No one ever said, oh, you know what? I don't think we're going to make it this week. He just, come on, we can do it. Everybody just move forward. And it trickled down to everyone, and it's working, right? Before I move on with the boiler controls, knowing what we went over, because it's always the same guys here, knowing what we went over in the past, are there any questions that you see every day, or you saw yesterday, something that you're not familiar with, something that you might not just be used to, that you want to bring here? It's open. It's an open forum. Don't think that we're here just to lecture, because that's not why we're here. We're here like an open forum. And that's kind of why I think we set the room up this way, so that everyone can get involved. All right? You have to be part of it. All right? So it's an open forum. I don't want anyone to be afraid to ask a question. I don't want anyone to be afraid to comment on anything. I don't know everything. I have one. I don't know everything. I'm going to be the first one to admit it. You guys see things that I might not see. All right? You might see it differently. So I'm open to comments. Okay? Also, is there anything that you want to see in a future seminar? Come to us and let us know. And we'll work our hardest to get it together. Okay? With that, any comments? None at all? Okay. All right, so we're going to move on. So we talked about boiler controls a few seminars ago. Some of you might recognize this boiler room. This is one that we did somewhat recently. 9411 Shore Road. I don't know if many of you worked on that. It was being done right through Sandy, and this is kind of why I picked this out. This job started before Sandy and got completed through Sandy and right after Sandy. And we met our mark. Even while the company was in somewhat of a turmoil, the job got completed on time and within budget. So this is what the boiler looks like. All right. On the boiler controls, you're going to see some controls here. We have our pressure controls, right? Everyone knows what they do. They sense the pressure, the steam pressure above the water line. Okay, the water line is right about here. So everyone knows that this boiler is full of water, right? And in that water is fire tubes. Above that is the steam chamber, and these are going to measure the steam pressure. All right? We also see an automatic water feeder here. And an automatic water feeder does exactly what it says it does, right? It automatically feeds water to the boiler as it needs it, right? And all it is a float control, right? As the water level goes below a certain level, it introduces fresh water into the boiler. We're going to go over different types of automatic feeders here tonight too, okay? So if you have any questions, don't hesitate to ask. Everyone knows what this is? Domestic hot water coil, right? Everyone understands that the domestic hot water never comes in contact with the water that's in the boiler. Does everyone understand that? The water in the boiler is just a pot of water. The domestic hot water coil is a coil that's submerged inside that water, and the domestic hot water just passes through that coil, and the heat is transferred from the outside of the coil to the inside of the coil, which makes our domestic hot water, okay? And then goes out to the building. Well, it'll go out to a tempering valve, and we'll go over that later, okay? So, some of our controls. And most times, you're going to see that the control's name is exactly what it does. So it's quite simple, right? We have our low water cutoffs. What do? They shut the boiler off in the event of low water, right? So it does exactly what it says. It's a low water cutoff. In most cases, on our boilers, you're going to see, at the very least, 2 low water cutoffs. Sometimes you might see 3. First one will always be a primary low water cutoff, and that's going to be set at the highest water level, let's say, right? Permissible for it to shut off. The highest working level. The second low water cutoff is always going to be a backup to the first low water cutoff. All right, and with that, the second low water cutoff or the backup is a manual reset type. Now, you may be electronic or it may be a mechanical device. Okay? Everyone understand that? A lot of times on our boilers, you'll always see the electronic one. The reason why it's manual reset is if that goes off, we know the first one's failed. Okay, so when we're in the boiler room, before we leave a boiler room, first thing we always do before we leave is just make sure that the low water cutoff is working. When we first fire up a boiler, and the electricians want to test their system, make sure everything's working properly, the first control you're going to go to is the low water cutoff. You're going to blow it down and make sure the boiler shuts off while it's running. Okay? It's the most important control on the boiler. Most important safety control on a boiler. Okay? I can't stress enough what happens to a boiler if it dry fires. It'll dry fire if that low water cutoff isn't working properly. Any questions on a low water cutoff? Okay, we're going to move forward. Pressure controls. We saw what they looked like on the other boiler, right, on the first picture. And they just sit up above the steam height on the purge. You're always going to have a primary, which is the 404F, what we're using now, and that's going to get set normally at 5 pounds. If the boiler ever gets to 5 pounds, it shuts off. Okay? In some cases, we may be operating higher than that. We may be operating at 10 pounds, and that's just on a different system, right? Sometimes when we're feeding a heat exchanger, we'll go to 7 to 10. But at 5 pounds, if it ever gets to 5 pounds, we don't want more than 5 pounds of steam in the building, so it's cutting off the boiler. After that, in case that control goes bad, same thing. There's a manual reset pressure control set at a higher setting, right? 10 pounds or sometimes even 15 pounds, depending upon how, what our 404F is set at. And that's same thing. It's going to back up in case the first pressure control goes bad. That one's going to trip out, and then someone has to go and reset it in order for it to come back on. And the reason why it's a manual reset is because it's going to tell somebody, hey, there must be something wrong with the first one, so that one has to get replaced. In most cases on safety controls, whenever there's a primary, there'll always be a secondary, and the secondary will always be of manual reset type. Can anyone tell me of another manual reset control on the boiler? Just pick another one that you have to manually reset for the boiler to come back on if it trips off. Spill switch. Spill switch is located where? On the barometric damper. What's the function of the spill switch? Exactly. Everyone understand that? It's a thermal coupling. So what it is everyone understands what the barometric is, right? It's the damper that sits on the breacher on the outlet side of the boiler. So if the chimney's blocked or if we don't have enough draft and the flue gases spill switch, right? If they spill into the building out of the barometric damper, that spill switch, which is a thermal coupling, senses the heat and it just shuts off. In order to reset it, you have to manually reset it because it's telling us that there's a problem. Okay, that's the reason for the manual reset in most cases. There's another one. Anyone know of another manual reset? You have to literally manually reset for it to come back on? Serviceman is easy. High limit aquastat is another manual reset, and that's on a hot water system. So instead of the pressure control on a steam system and a manual reset, you'll have the high limit aquastat, which is sensing the temperature of the water, and then the high limit above that manual reset. Okay? So it'll be either or. You won't have a high limit aquastat on a steam system or controlled on a steam boiler. You will have it on a steam to heat exchanger system. So on a hot water side, you're always going to have your aquastat and your high limit manual reset. There's one more, guys, that I'm thinking of. Everyone knows about it. Smoke alarm. The air contaminant detector. And all that is that beam of light that goes through the breaching. If it rings for more than 2 minutes, by law, you have to go and actually reset it. If you have to reset it, that means there's a problem. The problem might be that the lenses are just dirty, and they need to be cleaned off, or it's not set properly, or the bulb is broken, or the boiler's smoking. The linkage arms came off. A lot of times we see that, right? The linkage arms come off the burner and the boiler starts smoking because it's getting too much oil or not too much oil and not enough air. Air contaminant detector, there they are, smoke alarm. Temperature controls, another word for temperature controls. Aquastat. What does an aquastat do? It senses the temperature of the water, right? So in most cases, that control is doing exactly what its name says it's doing. It's an aquastat. You'll have your primary, you'll have your secondary manual reset, like Fabian said, on a hot water system. You'll always see an aquastat on all boilers. That's going to be an operating control, not a safety control. It basically turns the boiler on and off to maintain water temperature in the boiler, right? So it's an operating control. You're going to see safety controls, you're going to see operating controls. On a steam boiler, the aquastat is always an operating control, okay? With that, in the past, we've always set those aquastats at 180 degrees. We're trying to get away from that. The reason why is we don't have 6-oil anymore. We had to maintain 180 degrees to keep the 6-oil hot, right? So the side-on preheater would stay warm, hot enough to heat the oil. Now that we're moving away from 6-oil, there's no reason to keep the boilers at 180 degrees. So we've been toning them down a little bit. 160 with a 20-degree differential. What does that tell me? 160 with a 20-degree differential. It's going to turn off at 160 degrees. It's going to turn back on at 140. I have to make 130-degree water. There's no reason to make 180-degree water, okay? So as long as I'm maintaining 130-degree water in the building, I can keep the boiler 140 or higher. The reason why we try and go with a 20-degree differential is why? Less startup, less shut off, less cycles. Okay, it'll take a lot longer for it to get down to 20 degrees than if we put a 10-degree differential. Put a 10-degree differential, we're going to get twice the amount of startups, right? And turn off. So it's less wear and tear on the equipment, more efficient. All right, so 20-degree differential. A lot of times you'll see a DigiSpan, and all that is a digital control, right, as an aquastat. We have our Honeywell aquastat on the boiler that's just a probe that sits in the boiler. And the DigiSpan still has to have a probe in the boiler, but that's a sensor that goes back to the digital control. And we could set that at whatever we want. It's still an operating control, okay? DigiSpans don't necessarily just have to sense temperature. You'll see them doing other things, all right? They're a multi-useful control that can sense temperature, pressure, can sense vacuum, vacuum pressure, and so on and so forth, all right? So you will see a lot of times DigiSpan, and I have pictures of that, being used as an aquastat. Sometimes you might see the DigiSpan set at 180 degrees with a 25-degree differential. There's a certain engineer that likes that, and that's what he sets it. Actually, he wants it set at 195 with a 20-degree differential. When he comes, we set it at 195, and then when he leaves, we set it back down. He has this thing where he wants it, you know, a little higher. With 6-oil, it's great. We don't agree that it needs to be at 195 degrees, okay? Automatic water feeders does exactly what it says it does. It's an automatic water feeder. Someone doesn't have to come and manually fill the boiler by opening a valve. It's going to sense the level of the boiler, right? And it's going to automatically feed water into the boiler. Can anyone give me an example of an automatic water feeder? Automatic 51 feeder, McDonald Miller 51 feeder. All it is a bell, and it's a mechanical control. It has a float inside it. When the water level goes below a certain level, the float comes down and it feeds the water in. What else can we use as a feed control for the boiler? We see them all the time. You can have a solenoid valve. One more. Okay. Okay, that's a different control. What about a 150 pump control? Same thing, right? It's a level control, it's a float control, and when the float comes down, the only thing is, instead of it passing the water, it's turning a pump on, but it's feeding water into the boiler, okay? It's a feed control. That's pump controllers, okay? And our heating controls. Our heating controls are our heat timers, which we went over last meeting, the MPC Platinum. You could have a DigiSpan as a heat control. We have jobs that are steam conversions, right? That are feeding heat exchangers. We have one job right now, 145 4th Avenue. The primary operating control on the boiler for heat is a DigiSpan, and all it is sensing outdoor temperature. So when it goes below 55 degrees, it makes steam pressure because I have to feed a heat exchanger downstairs, right? Or I have to feed a motorized valve. So sometimes you might just see a DigiSpan as your heating control. Depends on what the system is. It's going to depend on what we use, okay? In most cases, it's going to be very simple. We're going to try and keep it as simple as possible, all right? And like I said, your controls will always do what their name says they do. Any questions on anything that I mentioned so far?
The human span has a temperature and pressure control. Is there an adaptive port that goes in place that goes under the...
Yes. There's a sensor. There's a sensor. It's a 4 to 20 milliamp sensor. And all it does is it sits on top of the perch, just like a pressure control, on the pigtail, right? And then it senses that pressure back to the DigiSpan control. A lot of times where you'll see a DigiSpan monitoring pressure is when it's modulating the boiler. It's called an MCP DigiSpan. What it does is it replaces the L91. The L91 is another pressure control. It doesn't shut the boiler on and off. What it does is it maintains the firing rate depending upon the pressure in the boiler. Okay? So you'll have three on a steam boiler. You have three pressure controls up there. You'll have your L91, you'll have your high limit, and then you'll have your manual reset. The L91, all it is measuring pressure. That's going to be set the lowest, right? So if we have our high limit off at 5 pounds, most cases we'll set our L91 at 2.5. When the pressure gets to 2.5 pounds, it starts to modulate the boiler down from high fire to lower fire to maintain that pressure between 2.5 and 3. So it doesn't get to 5, but it maintains that pressure in the system, okay? If that fails, then the high limit will shut off. If that fails, then the manual reset will shut off, and someone has to go and reset it, okay? You will see a DigiSpan as a modulating control. What's another modulating control? Where I won't have an L91 and I won't have a DigiSpan. You'll see it in 2, 3, 4 boiler applications. Multi-mod. Heat timer multi-mod. One sensor modulates the boilers and also sequences the boilers so that the two boilers can work as one system. Okay? That's the reason for the heat timer multi-mod. Whenever you see more than one boiler and it's a steam system, even on a hot water system actually, you'll always see a sequencing control. We use the heat timer multi-mod, okay, so that it senses the pressure of the system and it modulates each boiler accordingly and rotates the boilers. It does the work to make both boilers work for one system. All right? Any other questions? Okay. Can anyone give me another example of a heating control other than a heat timer? We've seen them. Thermostat, okay. Simple house thermostat is a heating control. Tecmar, okay. Smoke watchman, okay. There's another one that we see all the time. OAS is a computer control, very good. Dun & Bush, DCC 1000, MEPCO. What does that do? Controls a motorized valve. Right? It modulates a valve, a steam valve, it's like a Varivac system. It works on a Varivac system. Modulates that valve, sends steam to the building, and it variates it with the vacuum system. You'll see it on a 2-pipe system in most cases. All right? Very good, guys. Any questions? So here's our boiler controls on a boiler. Low water cutoff. This is the most common that we use. 67, right? Now remember, we said that this is a mechanical control. And right about here, there's a hash line. That's the level of the water in a boiler. We set that hash line at the normal operating, right at the top of the tubes, right? So if it ever gets to that level or below that, it's going to shut the boiler off. In some cases, you'll see a little reset button on there. If it's being used as the secondary low water cutoff, there'll be a reset button on there. In this case, that's what it is. The primary here is the 61. So on this particular boiler, we have 3 low order cutoffs, the 67, the 61, and we have the Safeguard OEM. These are both mechanical controls. When I say mechanical control, it's just a float that sits in there and sets the water temperature. If it goes below that level, it opens a switch. Remember last month we talked about the switches, and they're all wired in series. So if one switch opens, it shuts the boiler off. These are all wired in series. This one here is an electronic control. All it is a sensing probe that senses the water. So if the water goes below that probe, it's just going to shut the boiler off or open the switch. Now, very, very important, and you guys have to reiterate this to the building personnel. Any mechanical control that has a float in it has to get blown down when they blow down the boiler, which is normally once a week, at least once a week. Because what happens to sitting water? It corrodes. And what happens to a float that sits in sitting water? It corrodes. So what happens to a corroded float when the water goes down below a certain level? It stays in that position because the rust is holding it in that position. It will never drop down. So the importance of blowing down this control, the automatic water feeder, the 150 pump controller, is probably the most critical thing that a maintenance man or the building has to maintain. Okay? Not only are you exercising the float, making sure the float goes up and down, but you're also draining all that standing water that sits in there. Okay? A lot of times we go to the building and I'll ask them, we'll be doing seminars in a boiler room, and I'll ask the super, how often do you blow down a boiler? He says, I blow it down once a week. I said, how about in the summer? Oh, in the summer, maybe once a month. I said, why? This is because the boiler's not really being used. I said, wrong. Because the water is sitting in here, even worse in the summer, because the water's not being circulated. The water's never boiling. Even in the summertime, that has to get blown down maybe twice a week, because the water's sitting more so in the summer than in the winter, because you're not making steam, right? Understand, when you make steam, the water boils, right? So it moves throughout the boiler as it boils. When we're making hot water, all we're doing is just maintaining temperature. The water will sit there all the time. So I always grab them on that. The 150 pump controller, same thing. In the summertime, even though it's not being used, it's not pumping water, or the automatic feeder, it shouldn't be losing water in the summertime. You still have to blow that down to get all that crap out of there and make sure that that float gets exercised. All right? This is a side-on preheater here. You're going to see less and less of those now. You'll see us mainly taking them out, getting rid of them. They heat the oil, the 6 oil, right? And all they do, remember, the boiler water temperature, the boiler water sits on the outside of the coil. The oil goes on the inside of the coil. And just like a domestic hot water coil that sits below the water level, and it transfers the heat from the water on the outside to the water on the inside, this does the same thing. It transfers the heat for the boiler water that's on the outside of the coil inside this tube and transfers it to the oil and heats up the oil. That's why we had to maintain 180 degrees, right? There's also a circulator on here that circulates the water from the boiler through the tube back into the boiler. All right, everyone understand that, right? The reason for the side-on preheater? Just recently we used a side-on preheater like this as a heating loop. Right, Mark? In Queens. Similar to this is a side-on preheater, but instead of running oil through it, they're running water through it. And what they're doing is they're taking that water and making a heating loop for the first floor. But they're using the boiler water to heat the water for the heating loop. Right? All it is a transfer where one water doesn't touch the other. Okay? We saw it on 201 West 16th Street. They have a heating loop there as well. But it's a plate transfer. It's just a different type of heat exchanger. Sometimes we'll see something like this on a return line, on a vacuum system, where they, instead of bringing all that hot condensate back to the vacuum, they'll cool off the condensate and make domestic hot water with a heat exchanger. All it does is transfer heat temperature from the outside to the inside. And the domestic hot water coil works the same way, right? Okay. Here's our smoke alarm here, going through the breaching. All it is a beam of light. Everyone understands that, right? If the boiler smokes, the beam of light gets broken, shuts the boiler off. Anything else on here that we could see? Yeah. A lot of times you'll get that from the water treatment. Remember, the water has to get treated. All right, does everyone understand that? Why we treat the water in the boiler? No? Okay. If you take a piece of steel, just a raw piece of steel, and you leave it outside in the backyard for a week, and it's raining outside, what is that raw piece of steel going to look like after a week? It's going to be one big piece of rust. Now remember, these boilers are steel. I put water on the steel. What's going to happen to it? If I don't treat the water, it's going to rust. So we treat the water so that the boiler steel can stay maintained, so it doesn't rot the steel away. Okay? It doesn't rot the tubes away. A lot of times when we'll see a boiler that all the tubes need to be replaced. First thing you look at is you'll look at the water meter and see how many gallons they've been replacing on a system. It could be in the millions. And people are, I don't know. Yeah, of course you don't know. You didn't treat the water. Every time you introduce fresh water into the boiler, you have to make sure it gets treated. So the more often you treat water into a system, you have to treat that water, okay? Untreated water is very detrimental to a steel boiler. All right, everyone understand that? Okay. That's the main reason why we don't drain the trailers before we move them. Because remember, some of our trailers could hold 15,000 gallons of water. Now I have to retreat 15,000 gallons of water. Okay, so we do maintain the treatment, but if we had to do it every time, we're throwing all that treatment away, and it's detrimental to the boiler. All right? This picture's showing us our pressure controls. So here's our primary, here's our secondary. You can see the little red button here. It's faint, but trust me, it's there. All right? This one's set at a lower pressure, this one's set at a higher pressure. Remember what we said, the water level is right here. See the domestic hot water coil? Domestic hot water coil comes down and is submerged under water. This is the water level. Above that is an empty chamber, which when the water boils, will get filled with steam. Steam comes up, goes into the building. Goes up to this motorized valve. See right here? This is a motorized valve. This motorized valve is controlled by the heating control. In this case, in this building, it was a DCC 1000. What that does is it turns on the vacuum system and also modulates the valve according to the outdoor temperature. The colder the outdoor temperature, the more this valve opens. The warmer it is outside, the more it's closed. It just regulates the amount of steam going to the building. Okay? It's a heating control. All right? Same thing, 151 pump control right here. This is our 67 low water cutoff, pressure gauge. Everyone understands that, right? No other questions on that? I picked this slide here just because I want everyone to understand how the fire tube heats the water. So we have our burner on, and this is typical, right? We see this all the time. Every job we're in, you're going to see a boiler like this. The only difference between this boiler and the boilers we're using, this particular boiler is a 4-pass boiler, and what that is that says is that the fire is passing through the water 4 times and then finally going out. Our boilers are a 3-pass boiler. These would be the lower tube on our boiler. It goes through the blast tube, then it comes back out this way through the reversing chamber. So that front chamber with the doors is called a reversing chamber. So the fire comes through these lower tubes, then reverses through the reversing chamber, goes out and out the back. Okay? So as the heat goes through the inside of the tubes, the water level is right about this height, right here, right? Everything below this level is water. Everything above this level is steam chamber. So as this heats up, and all these tubes heat up because the heat's passing through them, it boils the water evenly throughout the boiler, right? So all the water boils. On a Scotch boiler, you'll see this water rotate. If we had a glass side and you saw this thing heating up and starts to build pressure, the water actually rotates through the boiler. That's why it's round like that, okay? And it builds up steam pressure and then goes right out the steam outlet. That's why our pressure controls are always above the water height, and our low water cutoffs will always be below the water height. Water height is a very, very important thing to understand when it comes to a steam system. All right, that water level is a very, very important thing to understand. All right, we'll get into it later on. If you guys want to go further down, we will. But it's real important, especially on a gravity one-pipe system. Remember that water height is maintained throughout the return lines in the building. Everything above that water level is going to be open pipe or steam. Everything below that is wet, it's water. So if there's a leak down the line in the basement under the floor, it's going to constantly leak because it's below the water line. And the automatic feeder will constantly feed water into that boiler. Does everyone understand that? Don't be afraid to say no, guys. Because trust me, I know there's a few guys sitting here saying, I really don't understand that, but I don't want to raise my hand because I'm going to look bad. You're not going to look bad. You're going to look even better. All right? Everyone understand that now, right? Water sits on the outside of the tubes, the fire goes through the inside of the tubes. We treat the water so that the outside of these tubes don't rot away. If they rot away, the tubes have to be replaced. On a 4-pass boiler, the exhaust will typically be right above the burner because it's going to pass once, then pass again through the front, pass again through the back, and come back to the front. On a 3-pass boiler, it'll typically be at the opposite end of the burner. Okay? First blast is going right through the tube, flame chamber, then it comes through the lower tubes, and then through the upper tubes, and then out the exhaust. All right? Cleaver Brooks boiler, you'll normally see a 4-pass boiler. Yes. All right? Everyone understand that, right? Why they call it a 4-pass and a 3-pass? How many times the fire passes through the boiler. Okay? I'm sorry? Which one is more efficient? The 4-pass would be, right? I'm sorry? Because that's what we built. 4-pass boiler is a lot more expensive to build. Okay? A lot more expensive to build. And as far as the efficiency goes, you have to weigh it and say, is it really worth that much? Am I saving that much more in fuel costs to build that boiler? You understand? So it's really not that big of a savings. Okay? Well, obviously, a 3-pass boiler will have less tubes. You know, you don't have 2 reversing chambers, right? You'd have to have an additional reversing chamber on the back. It's a 4-pass boiler is a lot more expensive to build. There's a lot more into it, okay? A 4-pass boiler will be twice the amount of money as a 3-pass boiler. Maybe not twice the amount, but it's more expensive. So as far as efficiency goes, are you really saving that much? Is it really worth it? Some guys will look at it and say, yes. Some guys will look at it, maybe not really, you know, if you weigh it out, okay? All right, so our electric panel, we see this on all our boiler rooms, right? Because they're typical to our boiler rooms. These are the DigiSpans we were talking about right here, right? All it is a digital control with a sensor. And the sensor's in a boiler, and you got a little temperature reading here. And with these buttons, you can set the temperature or the settings or the set points of where, and the differential, where you want the boiler to come on, where you want it to come off, what the differential is going to be. This is our smoke alarm, right? The manual reset. If this is ringing for more than 2 minutes, it's going to shut off. The only way you're going to turn the boiler back on is by resetting that button. All right, the manual reset is right on the control here on the panel board. This is the multi-mod. It's a 2-boiler system or better. Whenever you see a multi-mod, you're always going to have more than 1 boiler. Remember what we said that does? It sequences the 2 boilers or the 3 boilers to work for one system. It'll rotate the boilers. Every 4 hours, 6 hours, 12 hours, whatever we set it at, it'll make one boiler the lead, the other boiler the lag. What does that mean? The lead comes on first, tries to come up to pressure or to set point. If it doesn't make set point in a certain amount of time, whatever time we set it, then the second boiler will come on. In the warmer months, in most cases, you won't need that second boiler to come on. In the colder months, you'll need that second boiler to come on. That's the reason for it. And then it'll rotate. Every 4 hours, 6 hours. One will be the lead, one will be the lag. 4 hours later, 6 hours later, 12 hours later, whatever we set it at, the other one will be the lead, the other one will be the lag. So it evenly puts wear on each boiler, but both boilers can work for one system. All right? This here's our pump control. We see that on our boilers, right? In our boiler rooms. What that is doing is it's just turning the pumps on when the 150 pump control is called on the boilers. That float control makes a switch inside this panel, turns the pump on, pumps the water back to the boiler. This particular system here was an alarm system that we put on in this building that was tied into a BMS system, building management. So if any one of these lights, whether the boiler was on, the boiler locked out, the boiler smoked, the boiler was off on low water, the lights would come on, switch a relay, go up to the concierge desk, tell the guy at the front desk that there's a problem. You know, every light that was here, there's a light upstairs at the desk telling them, you know, what's going on with the boiler. If the power's on, if the boiler's running, if the boiler's off, you know, so they can monitor it from somewhere else. It was also tied into a auto dialer. So if it ever went into lockout, the dialer called somebody's phone and left them a message telling them that the boiler's out. So you may see this from time to time. We built a few of them in the past. All right? Any questions on here? No, of course not. This is the DCC 1000. Remember we talked about the motorized valve? That's controlling the motorized valve. All right? This is the control that allows the amount of heat or determines how much heat is going to the building, depending upon how cold it is outside. So in this DCC 1000, just like a heat timer, there'll be an outdoor sensor connected to it, and then there'll be wiring connected to the vacuum system, and then there'll be wiring connected to the valve on a steam line. It'll turn on the vacuum system when it calls for heat, when the temperature goes below whatever temperature we set it at outside. And it'll open and close the valve depending upon how cold it gets outside. It just regulates the amount of steam going into the building, all right? Now, one thing about these systems here, they're not a cycling system. It's not we close the valve all the way, wait an hour, then open the valve all the way. It's a floating valve, okay? It modulates that valve and it maintains a certain amount of heat all the time through the system, okay? So that's why it modulates that valve and distributes that heat into the steam system, depending upon how cold it is outside. Obviously, the colder it gets outside, the more steam goes in. All right, everyone understand that? Here's our multi-mod. I know it's a two-boiler system. One other thing that's telling me is I got two electric panels. On a two-boiler system, you'll always see two separate electric panels so that we can isolate one boiler from another. These are our DigiSpans. This is our auto dialer. This particular boiler room, if I remember correctly, these DigiSpans are two-stage DigiSpans. When I say two-stage, it just means it has two separate set points. The first set point is turning the boiler on and off for water temperature. So it's one sensor in the boiler. The water temperature goes below, because this was 6 oil at the time, went below 180 degrees. It turned 160 degrees, it turned the boiler on. At 180 degrees, it turned the boiler off. The second stage set point was set at 140. If it ever got below 140, it signaled the auto dialer, and the auto dialer called the super on his phone and told him there's a problem with the boiler because the water temperature is below a certain level. We could set that at 120, we could set it at 110. We picked 140 because it was 6 oil. If it goes below 140, you know that there's a problem. You know, nowadays, if it's 2 oil, we'll set it at 120. In most cases, by the time he finds out, he has more time before people start calling if they don't have hot water. All right, so in this case, there were two-stage controls. First set point, turn the boiler on and off. Second set point, told somebody that there was a problem, but only one sensor. So we have that availability with a DigiSpan. It'll be a TSC, two-stage control. All right? Again, our smoke alarms. These are our controls here. Everyone understands most of us should understand. You'll see these on all of our boilers, the orange, the red, and the green light. Green light is, if the green light is on, it's off on low water. The red light is on, it's on lockout, there's a problem. Orange light is on, that means the boiler should be running. If the orange light is on and the boiler's not running, you have to find out why. There's probably a problem in the burner cabinet. Oil pump relay, fan relay. You'll always see that. If there's a fresh air fan coming in, there'll be a relay that just turns the fan on and off when the boiler turns on and off, or the oil pump turns on and off. So our typical panel boards, okay? Any questions on the panel boards? You guys that are plumbers that see things that you don't know what it is and you want to learn about it? Everyone knows what this is, right? It's a makeup feed tank. Basically collects all the water from the system, collects it into this tank, and as the boilers need, the pumps will come on and pump water to the boiler that the pump is connected to. This particular case is a two-boiler system because I have two outlets going on out to the boilers. One pump for one boiler, one pump for the next boiler. This is a standby pump. It can work for either or boiler. So if one pump goes bad, the center pump can act as the standby and give us time to replace this one pump. The main reason why I put this in here is because of this control right here. All it is a float control, right? All it is a bell that sits in the water that floats on the top of the water. And as the water goes below a certain level, it makes a switch. When it goes above the certain level, it breaks the switch. We can set this. This has settings on it. We can make the difference this much. We can make the difference this much, meaning the on and off, right? We can set that. It's important that whenever we set this up, there's a little set screw that sits right here on the center of that pin that the float is connected to. We have to make sure that that is as tight as you can possibly get it. because too often enough, this thing vibrates. And that thing comes loose if it's not tight, and that falls off. If that falls off, one of two things will happen. It'll either fall off in the on position. This makes the solenoid. So if the water ever goes below this level here, the solenoid is going to activate and feed fresh water into the tank. So what happens if this breaks in the closed position and it constantly feeds water into the system? It's going to overflow the tank. And in our cases, our overflow is tied right into the sump pit, right? So is anyone going to see that the water is overflowing? No. Exactly right. The shaft itself is rounded on one side and it's flat on the next side. You'll see when you tighten that down, it has to be sitting flat on that flat side of the shaft. That's what holds it in place. If it's not on, it's going to come off. It's not tight. The only way you're going to get it tight, or you possibly get it tight, is if it's on the flat side of that shaft. Now, understand, this is just a flow control, okay? It can do one or two things. It can either turn or close the switch when the water comes below a certain level, or it can make the switch when it comes below a certain level. In this case, it makes the switch. It closes the switch and sends power to the solenoid valve to fill the tank up with water, right? A lot of times we'll come in and we'll connect a trailer and we'll see this tank and we'll say, oh, this is great. We got a tank like this. I don't have to put the condensate tank to pump the water back to the trailer. I'll just use this tank. And you'll see me take this here and put a temporary control, disconnect the solenoid valve, and wire this into the pump control. And what we'll do is we'll say when the water now comes above a certain level, it's going to make the switch. We have to rotate this around. Okay? It can go either or. So now when it comes above a certain level, it's going to make the switch, turn on the pump, pump the water back to the trailer. Okay? That's why I wanted to point this out. This switch is, too often enough, we go back to the boiler rooms and there's a problem. Either the water is just constantly overflowing into the sump pit, nobody realized it, or there is no water, the boiler went off on low water because there's no water in the tank, because the system went dry, because this never came on. And it's always that little clip that sits on there. All right? It's a good design as long as it's maintained properly. All right? There's one set of engineers that typically want a low water cutoff on this tank. What they're saying is if this fails and the water goes below the second level or the level of low water cutoff, it won't allow the pumps to come on so that the pumps don't run dry. Every time we've done that, we've always seen a problem, especially with electronic control. The electronic control just didn't work right. You'll see a mechanical float on the side. Sometimes they'll put a 51 feeder right on the side of the tank. Instead of having this flow control, the 51 feeder and solenoid valve, it'll actually feed water into the tank, but then it'll have a switch on top of it, so if it ever goes below that level, it just won't allow the pumps to come on. All right? Or I've seen a 67 low water cutoff sit on the side of that. You have to actually go purge and everything, and you got to go and blow it down. So, you know, everyone always forgets about that. You know, most cases nobody goes back and looks at the low water cutoff on the tank and blows it down. I can guarantee you every time you see one, 9 times out of 10, that thing is stuck in the opposition anyway, because nobody's blown it down for 10 years. All right? Any questions on the tank? A probe low water cutoff will work. We've just noticed when we put them on this plate, close to this outlet, the velocity of the water as it's being pumped through this manifold tends to affect that probe. So we've done it a few times, and it's been a failure. All right, it's just, the velocity of that water going through here affects that probe too much, and it just shuts off. It's sensing the water, exactly. But like I said, the velocity of that water going through that and coming down that plate, it's affected it. And it's just, we don't do it because it's been too much of a problem. Yeah. Most cases, yes. Not all the time. Absolutely. If it's a dry system, you're going to have all your traps, steam traps, drains from the steam traps tie into your tank, right? On a two-pipe system. If it's a wet system, a lot of times you'll see us just have a makeup feed tank and overflows on the boiler. If the boilers get to a certain level, it just feeds back to the tank, but it's still a gravity return. It all depends on the system. Yeah.
And all of a sudden, you see the tank starting to vibrate. What does that mean? Does that mean you have bad trap?
Do you see steam coming out of the tank? If you have 5 pounds of steam in your system, and there's steam billowing out of the top of this tank where the air fitting is, steam billowing right out of it. If it's 5 pounds of steam in the system, and that trap is bad, you'll see steam coming out of that tank. Remember, 5 pounds of pressure is a lot of steam pressure. 1 pound of steam pressure, you'll see steam billowing out of that tank. Obviously, that means one of the traps is bad. Yeah.
I know exactly what you're talking about.
Yep.
It sounds to me like they had a water seal pipe that went up and then a pipe that went down prior to try to keep the returns wet. And the pressure, the 5 pounds of pressure probably overcame, pushed the water up and over that water seal. And either there was no trap before the tank or that trap was failed open and it just blew steam right through it. And that rumbling, I've heard that when it's live steam with no steam traps. I've seen that on Fifth Avenue. You and I were just thinking.
149 Fifth? Does everybody get what Danny's talking about? Here's the tank, okay? We have our return lines coming back from the building. They come across the floor this way. And this comes up above here and goes into the tank. This here is higher, sorry. This, because it's a loop, is a water seal. The water level is at this level, right? Because as the water drains in here, it's coming through here, and it can only drain into the top of the tank. What Danny's talking about is the distance between here and here. We talked about this a couple of seminars ago. 28 inches relates to 1 pound of steam. So if I have 54 inches here, right? How much pressure can I put into this? 2 pounds, no more than 2 pounds, because what's going to happen is the pressure, down pressure, is going to push this water up to here, and now I'm going to get steam right here. What happens when you get steam and water on a vertical plane? Bang. You can always get, right. Now add 5 pounds of steam pressure to that. This and this, it blows all the steam right through into the tank. And he gets his tank, it's vibrating. Yeah, everything will start to crack. The chandelier on the second floor will start to crack. We've all heard it, right? Steam banging. It's not just the bell ringing. Okay? Everybody understand that? The water seal and the pressure? 1 pound is equal to 28 inches of water column. This is a water column, okay? So that's why a lot of times you'll see Danny leave notes on the pressure controls or in the burner cabinets saying 1.5 pounds maximum on the system. There's a reason for that, because he knows that there's a water seal somewhere, and that water seal is no more than 40 inches. It can't withstand more than 1.5 pounds, because you're just going to get all kinds of banging. All right? Great question, Andre. Anybody else? Everybody can relate to that, right? You understand it? Okay. We saw this a few seminars ago. I just wanted to bring it back. Remember we talked about the domestic hot water coil that sits in the boiler? When we're making steam, what temperature does water boil at? 212. Sometimes you'll get that boiler water up to 230 degrees. So if I have a submerged coil sitting in 212 degree water, what's the temperature of the water coming out of that coil? 212 degrees. Can I send 212 degrees to people's bathtubs? No, because they're going to burn them. So what do we have? We have a mixing valve. Okay, takes the hot water from the boiler coil, blends it with cold water, and regulates it and sends it to 130 degrees out to the faucets. All right? This particular job, because of the size of the building, had 3 separate returns. That's the domestic hot water returns. 3 separate pumps coming from different areas of the building. So what it's doing is it's circulating the hot water through the building and bringing it back and constantly circulating it through the system. In a large building, if I have a 20-story building and, you know, each floor is 15, 20,000 square feet, Mrs. Jones up on the 21st floor, if she has to wait for hot water to come from the boiler room, she could be waiting 3 hours before it gets up to a piece of 2-inch pipe, right? So we constantly circulate that water through the system so that when they open their faucet, the hot water is already there. What happens to this water as it comes back? What do I do with it? I have to dump it back into the cold water supply that blends with the cold water coming in here and back to the coil. So it constantly circulates it through the system, always knowing that the mixing valve regulates the temperature going out to the faucets. So it constantly runs it through the system. This mixing valve should always have water running through it. These circulators should always be running. Okay? A lot of times we'll get calls that say there's no hot water. Go down there, the boiler's working fine. Temperature's good. What are you talking about? I got no hot water. I got 130 degrees coming out of the mixing valve. But we look at the circulators and we only have 80 degrees coming back. Circulator might be running. Water might not be moving. The reason why they don't have hot water is because they have to wait 3 hours for it to turn on to get up there because it's coming from the basement. So a clear indication is just check those circulators, make sure the circulators are working and that the water's coming back hot. See these cocks right here? That's coming back from the building. Open them up, drain them out. Maybe they're airbound. Maybe we just have to get the air out. I remember one call from a super on a Saturday morning. We just put the boilers in about 3 weeks before that. Calls me up, he says, I don't know what the problem is, I got no hot water, but the boilers are running, you better get over here right away. Because it's Saturday and it's my day off. And my people don't have hot water. So, all right, did you check your domestic hot water circuit? Yeah, it's running. Get down here. So we ran down there. Anthony and I actually were together that day. And sure enough, system's airbound. We open up the circulator, water's coming back cold. So I asked the super, I said, hey super, did you shut the water off at all this week? He says, yeah, I cleaned the roof tank on Friday. I said, when you turned it back on, did you bleed the system? What's that? What's that? You got to get the air out. You fill the system all up with air, right? Circulator can't circulate air. It can only circulate water. So we ended up dumping the system, draining the line for about a half hour, put a hose, turn it on, let it run. Finally, the water starts coming back hot. guy had hot water, but it was our fault. Yeah.
Some of those calls, with people complaining about the mixing hot water, a lot of times I'll have guys on the job and I ask them, circulator working? Yes, it is. But they're still complaining. Mixing valves producing, boiler's working. I'll just tell them, do me a favor, just pull the pump out. A lot of times, when I pull the pump out, because it's not this time.
The what?
The impeller, the pump impeller,
Right.
heated.
Oh, well, the plastic ones you're talking about? She's one. They make those in China now.
Yeah, but we always put a temperature gauge on a return line. If the temperature gauge is 80 degrees and the outlet temperature is 130, obviously the water's not coming back hot. So there has to be a problem either with the circulator or the line is airbound. Okay? Another style mixing valve. All right? The mixing valve we saw before is a mechanical valve. This has a thermostatic element in it and a piston, which works mechanically, that opens and closes to regulate the amount of cold or hot water going through it. This one here is an electronic mixing valve. Has a sensor on the outlet side of the mixing valves, and it opens and closes these valves with an electronic motor depending upon what the set point is on the sensor, which we can set, right? Everyone understands how that works? Hot water comes from the boilers, cold water comes from the street or the return water, mixes the two here at the valves, and then sends the right temperature up to the, look at the temperature gauge here. That's 220 degree water coming in. See the temperature gauge here? 130 degree water going out. You see where it's facing up and this one's facing all the way out? These are 250 degree gauges. All right? And the water temperature coming back from the circulators and the street is probably about 90 degrees. So we're not raising that temperature all that much here at these mixing valves, right? Because the temperature's coming back from the building. Probably only have maybe a 30 degree difference between this pipe and this pipe. All right? Yes?
This setup.
Mm-hmm.
How do you size these mixing valves to accommodate the person? Based on what?
It's size per family of building and how many fixtures there are in the building, right? So this particular building, look, we got 4-inch going out, right? They don't make a 4-inch electronic valve. That valve would be, you wouldn't be able to lift the motor if they made a 4-inch valve. So we put two 2-inch valves in parallel so that it would have the proper capacity to feed this size building. This building here, if I remember correctly, is Seaview Towers out in Rockaway. Big buildings, about 400 families each. All right? I think a 2-inch valve is up to 210 apartments, 240.
Per hour, have a chart. If you really want to know, I'll give you a chart. Very simple.
We have charts that we go, right, gallons per hour. Yeah, it's 350 horsepower boilers. I think each coil is a 6,000 gallon per hour coil in each boiler. So there's a lot of water. Remember, it's feeding all those families at the same time. So it's a big building. But it depends on the size of the building, obviously. All right?
The head temperature adjusted to modulate slowly or aggressive?
These will work in parallel. You can change the settings on how aggressive they are. It's the gain. And all it is the gain, plus or minus 10. They'll work just as aggressive. The more aggressive you make it, the closer it'll come to that set point. The less aggressive you make it, it may swing a little bit more, to that set point. So,
Why would you want to change the game? What would be the benefit of higher or less gain?
sometimes depending upon the load, guys, or how many people are actually drawing, that valve might be doing this, constantly up and down. Maybe there's air in the line, maybe the water's not moving properly, the valve is just gonna start hunting. Instead of just steady flow, open a little bit, close a little bit, the gain will do that. It'll make it more aggressive or less aggressive. If it's hunting, that means it's trying too hard to get to that 130 degrees, but it's at 128, and then it goes to 132, and then it goes back down to 128, and it's just constantly doing that. If we lower the gain, -2 or down 2, it's gonna slow that process down a little bit. All right, it's gonna look for it, and it's gonna move it, and then it's gonna wait. Did I get to it? No, let me move again. All right, that's what the gain does. It makes it less or more aggressive. You can go +10, you can go -10. All right, the default setting is 0. All right, gain, G-A-I-N. That's what you'll see it under. All right. Any other questions on the electronic valves? Nowadays, you'll see the heat timer, ETVs. It's a green control, green and white box. Pretty simple to set. All right. I think that's it. No, we got one more here. This is just showing the old style heat timer, MPC, EPU. We went over them last seminar. This is the new ETV control that I just talked about with one mixing valve. This particular building, if I remember correctly, this one was Wadsworth Avenue. No, not 320. 320 Wadsworth Avenue, right? Yeah, that was the building that went off fire. So that building, I think, is only about 130 apartments. I think this is 1.5-inch valve, 1.25 inches. Depends on the size of the building. All right, and we have our circulator right here. Just a single circulator, smaller building, right? Coming back, dumping water back into the cold. Typical Abilene panel board, right? Everybody sees them on all the jobs. Also, that one has a regular small boiler in the back. That's why the pipes are going 2 ways. Right. Anthony's 100% right. On this job, they have a boiler, and then they have a hot water heater in the back, a gas-fired hot water heater. In the summertime, they switch over. So they're not keeping the boiler hot to make hot water. They're making domestic hot water with a small water heater in the back. It's a small enough building they can do that, and a storage tank. So there's teas and water supply coming off of the back, and these are going back to the coil here. Any questions, guys? I think I'm over my time, right? Am I over my time? Hector? Yeah.
Most of your jobs, you also see the network sensor that you haven't spoken anything about those network sensors. I believe you have them upstairs in the hallway.
Right. Yeah. What Hector's talking about is, and I thought we touched base on it on the last, when we talked about the MPC Platinums, the RI Nets. There's a network manager, which all it is just a white box that links into the heat timer control. What that network manager does is it takes readings wirelessly from apartment sensors, and it puts it into the control. And not only does it look at the outdoor temperature now, it also looks at the temperatures in the apartments. So sometimes you might see that box, it says network manager or network power supply, or you'll see a modem box sitting on that panel. A lot of times it'll be right above the heat timer, and there's an actual computer modem sitting in there with a wire coming in, Cat5 going into the control. It's just like having a computer at home. It's accessing the internet. And over the internet, I can get into it from my computer at the office, or the manager can get into it from his computer at home, or from our laptop sitting on a bus, and control that heat timer. Just like being at the heat timer, we can make settings, changes. You'll see that more and more as you get into newer buildings, because everyone's putting them in. They're a lot more efficient. Taking the apartment temperatures into account saves fuel. Obviously, when in the summer, in the fall and the spring months, April, May, where we're still required to provide heat because it goes below 55 degrees outside, but it might be 53 degrees outside, and I might not have to run a cycle every hour, hour and a half. So we look at the apartment sensors and say, if everybody's 72 degrees outside, in the apartments, I only have to give them 68. Why am I making heat? Because it's 54 degrees outside? No, we're going to wait. And we're going to, leave the boiler off until those temperatures come back down.
Now,
That's what Hector's talking about.
Now, these temperatures, 70,
Yeah.
or the temperature itself, there's no way you can read them off in the boiler room?
You can't, the only way you can read the sensors up in the apartment at the control, if you scroll through the control, it'll tell you the space average. And space average means the average of all the apartment temperatures is that temperature.
Is that going to tell you?
It's not going to tell you, you can only see the individual apartments from the internet, or from that control, from that connection, at your computer. You can't see them at the control. The only ones you can see at the control is the average of all those sets. And the reason why you can see the average is, because the average is the set point. That's what it's looking for. If it's 72 degrees, and our set point is 73, that means the heat should be on. If it's 72 degrees, and our set point is 70, the heat's going to be off. That's why it's giving you that reading at the panel. You'll immediately know that it's not calling for heat. It depends. If I have 20 sensors in the building, and I know 3 apartments are way out in left field, I can read them, but I don't have them voting into that average temperature. I can make it anything I want. I can make it one sensor, I can make it all 20. Whatever I want it to do, or whatever the building wants it to do. All right. On the heat timer, we have a lot more control. A lot of times you'll go in, you'll see OAS systems, you'll see the, Jerry Pindas is one. US Energy, or NTEC. We don't get into those. We let the management company call the heating company and let them get into it, because they're controlling it on the internet. All right, the heat timers, we have control over them, in most cases, if we install them. Alfred.
I was on job one, and those systems will keep in boilers for the moment. I have asked the super to put some ice in the back of the ice can and strap it to the sensor in order to make some more heat on the weekend. Because their office is closed and they cannot.
Excuse me. All of them will have a bypass.
Well, they want to put on bypass.
All of them will have a bypass. The heat, just like the heat timer has a bypass switch to give them heat, turn it on and give them heat.
Put it on bypass.
Because they're going to get in trouble with their manager. But as far as, see, as a service company, we have to say, look, put in bypass, the boiler fires. It's making heat.
That's what I did.
Turn it back off. You have to control your heat. You didn't set them. Give them heat. Give them an hour worth of heat, and then, tell them it's good.
I didn't need it. I had enough heat.
Yeah. I don't know if, putting ice cubes on top of the sensor is the right fix. But
Put it there, cool it down. You can heat 5 minutes.
okay. Raise the aquastat to 220 degrees for a half hour. Do I have to go buy ice? I mean,
I didn't want to go to the building.
okay. Anybody else? Any other questions, comments, experiences? Nothing? All right, what are we doing next time? What do you guys want to talk about? I know you're not just coming in for the food. Come on, guys.
Get into a little bit of the bagging and vacuum systems, how they operate, what's the principle.
Steam systems?
Also just
We could do a whole night on steam systems. I'm sorry, what? LMV? How to set up the LMVs? We'll bring somebody in to do that.
You can get a burner here with an LMV.
We could bring a burner in, we could do a mock system. We could do that. Huh? Bring the whole system. Bring the whole burner and everything. Yeah. We could do that. How about gas boosters? You guys want to talk about gas boosters? We're seeing a lot more of that now, right? EDDR VFDs. And how they work. Everyone understand what a VFD stands for? Variable frequency drive. And all it does is it increases the speed of the motor or decreases the speed of the motor depending upon the pressure at the end of the line. Right? So the control has a certain set point that it's looking for, inches in water column on gas pressure down the end of the line. And depending upon the load, that speed will increase to give more pressure or decrease to give less pressure depending upon what the setting is. All right? We also see VFDs on exhaust stow systems. That's the mechanical draft control. Right? We can do a whole nother night on that. Listen, there's no end to the information. And no one is perfect. I mean, I'm learning every day too. And my father told me a long time ago when I was a kid, he says, the day you're done learning, you're done. Never stop learning because there's always new stuff coming out. And no one knows everything. And I'm going to be the first one to admit, I definitely don't know everything. I'm learning every day. So, I ask questions and I read. If I don't know something and I don't feel confident about something, I'm going to try and find out as much information as I can. And in today's day and age, with the internet, we have it on our phones. You can ask your phone a question and it'll tell you, what the answer is. Where's the best place to buy a gyro in Bay Ridge? And they'll come up with 10 of them. It's anything, right? So there's really no reason for saying, no one can really say, you know what, I don't know. And I can't find out. The information's always there. And especially when you have guys that, resources like yourselves and us. Just ask the questions, we're here to help. We're here to work as a company, as a whole, so that we can all help each other out. All right? I'm sorry, one more?
The motor sits in the gas, the booster full of gas. Does that motor carry brushes? What stops that motor from igniting the gas that's already inside that booster?
What do I need for combustion? What are two things I need for combustion? What? Okay. So if it's a sealed system, where's the air coming from?
The motor is a steel motor.
The whole system is sealed. Right? You need fuel and you need air. Without air, you can't have combustion.
Because there's only gas, there's no oxygen in the gas, so it can't ignite. Okay.
That's how it works. All right? Any other questions, guys? No. All right, so we're going to take a break now. I think the coffee's just about out, and then we'll pick up again, all right?